the x? We call that our slope. What is with the b? So pretty straightforward. Sometimes people forget the negative sign and ignore that. So we have to find the right combination. Is D. All right. The equation for the line with a slope -3 and a y-intercept of 4. So again, you get really good at picking out this information after a while. And so we have the -3 here and a +4, so that must be our answer. Okay. Probably no difficulties at this point. We'll try and get to the short answer and the extended problem soon. The rate of change. Well, again, what are we talking about when we talk about rate of change? We're talking about the slope. So we've got to look at it here. So, all right. What if we try something a little different here? What if we ask a question, and then you guys can write it over here. So, does everyone see the screen again? All right. So, equation of the line through these 2 points. Well, this gets a little more tricky. So, why don't you guys try this? And then first to give me the answer, we'll have a bit of a race or something. Who can come up with this answer? So if you can come up with the answer and then you write it down in the chat. You might start off by, you might remember an equation like this. And then you could find out slope. The clue here is also that we already know the y-intercept because the x term is 0. So we do know the b. I'm going slow on purpose because maybe one of you will answer this for me. I don't know the answer. Come on, Jacob, you can do it. So we know, well, even from process of elimination, just knowing the b, you know that it can't be these two. Jacob thinks it's C. Okay, so we need to go and do our -1 minus -3 and 0 minus -1. So we have -1 plus 3 and +1. So that's going to be 2 over 1. Okay, so slope is 2 over 1. Which one has, so Jacob, yeah, it's going to be D now, right? Because it's a positive slope, +2. All right, moving along. So you want to double check, like, so at first glance, C looked like a good answer, but we do it more carefully. And with these, you got to pay attention to these double negatives that show up. All right, so we flip on the other side because of the photocopy. I think these are, looks like we're kind of missing a question, something for that number 6 question. But, well, I guess it's just 6A. Okay, determine the rise and the run, then calculate the slope. All right, so we know how to do this. We're pretty good at it. They also gave us really good points to start with. So, and we don't think it's going to reduce because it's not hitting any other grid lines along here. So it's going down 3, and we remember that's always a negative when we go down. To the right is +7. Turn the rise and run. Yeah. Okay, so we would say for 6, we'd say the rise is -3. The run is 7. So the slope is -3, -3 over 7. And Jacob is on it, right? And I'm glad you wrote it that way, Jacob, because we actually don't, like, if you want to be more proper, the slope goes with the x. We don't actually write x as part of the slope. So you don't include that because x is its own variable. So x means something else. X means the number of hours the person worked or the number of months they paid off their car. Like, let's say they're paying off their car. This would be how many years it took or something like that. So x just represents some other number. All right, so number 7 on grid paper. Well, we don't really have any grid paper. Graph each linear relation. Well, that would be tricky. So let me think about that. Where can I get grid paper? Do these all in different color. Okay, so, well, this one's arranged differently, so then it's tricky, but basically we're going to start off at 5, and we're going to go down 1, over 1, down 1, over 1. You can do the several of those, and then you graph your line. All right, y equals -9, and in this case we have no b. There's no b, so plus 0. So we start here at 0. We're going down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. Then we graph that. Hopefully you're able to have that, do some of these questions before coming on today. Sure, that goes nice. Okay, and then we can do red for this one. So pretty easy. Slope is 1, and the y-intercept is 0. So we're starting again at 0, 0. This time we're going up and over 1, up and over 1, up and over 1. Hard to get it right on the first try. That was pretty good. Okay, for graphing. All right, finally, slope of 1 and a y-intercept of 4. So starting off, let's go with purple or something. So 4 up here, going up and over, up and over, up and over, up and over. A line, purple or something. One thing you then start looking for is like what's common between, what's common between those two, D and E. Well, we start to see that they're parallel, even though one's a little off, but it looks like they're supposed to be parallel. So they'll never touch in space. All right. Well, the next question has to do with the ones we just did. So refer to the graphs in question 7. Identify the lines that have a positive slope. So you can either look right into the equations, but basically, if we called our blue one was B, our green one was A, our red one was C, and D. So which of the lines have positive slopes? So the two sloping up in an upward motion, D and C. Identify the negative slopes. Well, A and B. Identify, because they're going downwards. Identify the y-intercept of each. Again, you could, without graphing, you could pick all these out from the equation, but we have a positive 5, we have a positive 4, we have and 2 zeros. Right? The equation of a line that is parallel to each line. Okay, well, we're running out of space here, but let's say over here we could say on this side. A parallel line to this could be y. So let's just say we have our questions up here. Y equals anything negative 1x, I don't know, minus 4, as long as these are the same. Another one, anything parallel to that. So y equals negative 9x plus 2. As long as the y-intercept is changing, it's at a different point than 0, those would never meet. And then red, okay, well, y equals 1x, and then anything you want, so minus 7 or something like that. Finally, y equals 1x plus 8 or something like that, as long as the slopes are the same. So hopefully that's okay. You can all give me an okay in your chat if you're feeling good about that. Determine whether the lines represent, so for number 9, by the tables are parallel. So the only way we're going to know that is if we find out the slopes. So finding out slope from a table of values means checking the first differences and the x increment. So we can see in both that they're just going by ones. So we just want to double check that so that we don't it doesn't start skipping by more than one. And here too goes by ones. So that's good. That means that our denominator will be over a 1, making it a lot easier to find out. So I think it's pretty obvious. You guys can tell that we're losing 5 each time. So we can say that there's a rise of negative 5, and our slope would be negative 4, or negative 5, sorry. Okay, over here, a little more room to play with on this side. Same thing, we got going by ones on this side and going by negative 1 here. So you can say that, negative 1. You say that it's negative 1 over 1, and slope is negative 1. So determine whether these lines are parallel. So no, they're not parallel. Write an equation for the first line. So how do we do that? Well, we look right here. We get our b. We look here and get our b. So for each line, so this line, y equals, well, we have our slope, negative 5x minus negative 5. It's just a coincidence that those are negative 5s. There's nothing, clearly wherever it's 0, then we're going to get that. Oh, right. Good. All right, so a different color here. The next one, so y equals negative 1. Again, it's up to you whether you want to write that 1 or not. I guess the more proper way is not to write it, but I kind of like to see it sometimes, just since I'm working out slope. And then our y-intercept is 0, so we don't actually write anything there. So you don't actually, you can write it, but then it really shouldn't be there in the final answer. Okay, hopefully this isn't running, hopefully this is easy for you. I mean, we learned it over 2 weeks ago now. So, all right, solve the values of y given the values of x. So we are going to substitute those in there. So let's do 10a over here. We have to do it twice. So y equals negative 0.25x. So we say y equals negative 0.25. And then in the x, we bring that 4 over. Okay, y equals, well, two negatives make a positive, and a quarter of 4 is 1. Sorry about that. Okay, so next we have a y equals negative 0.25. You can see here. We'll put the number right in there right away. And so y equals, so we have a negative, and a quarter of 8 is 2. So when x is negative 4 and when x is 8, those are our 2 points. Okay, now substitute for this one. Not yet. Okay, sorry about that. Y equals, we can have that ready for both. So y equals 5 minus 3x. So for x, we put negative 1. And on this side, we're bringing the 0. So I'm having trouble with this markers today. Y equals 5 plus 3. Y will be 8. All right. Just a second here. All right, we're good with this? All right, I want you guys to try number 11. No one's fallen asleep yet. All right, so I mean, there are algebraic ways to do this, and there's the slope formula that we can get slope from, but we do want to pick out anything that we might have as a clue. So right here, we're going to know from here that b is negative 4. And so you might want to graph this, or you could do the slope. You could do the slope equation, but we didn't do a lot of that. We did mostly graphing. So if I go negative 0 and negative 4, and I go negative 5 and negative 14, oh, it's way down there. So that's going to be the problem then. Ah, that's not good. So we might have to do it mathematically or algebraically. So let's do that. So if I have a y2, it's the second y, negative 14 minus negative 4. Ah, let's try that again. So negative 14 minus 4, because it's a double negative. And then the second x is negative 5 minus 0. What are we going to have for a slope now? So we have negative 14 now plus 4 is going to be negative 10 over negative 5. Well, that will reduce nicely to positive 2. Okay, so we have a slope of positive 2 and a beat of that. So 11a y equals 2x minus 4. Oh, I forgot the negative here. Okay. So this is kind of important, right? This is a little bit more difficult type of question where if you can't fit on the grid, we could have, now we know what we could have done. We could have changed our grid to go every second number. Maybe that would have helped us, but ended up being a pretty easy number, like positive 2. Okay, so let's go through this one then. Now this one's a little more tricky, but it will fit on our grid, so that's a plus. So 4 and negative 2. We got to find our next spot, negative 5 and 7. So try to ignore all this other mess. It's not going to be a problem. It's not really going to be in the way of what we're answering. Let's get a green line here. Go through these 2 points and adjust as needed. We want to be as accurate as possible. Okay, so if we count, now it turns out this is pretty clear that it's going down 1 over 1 because it's hitting the grid every single point. So that's easy enough. If you ever wanted to, you could say, okay, it's going down by 5. It's going over by 5, which reduces to negative 5 over 5, reduces to negative 1. We kind of knew that because it was going down each grid line. So now the thing we need to look for is this point. What's our B? So our B is going to be positive 2. So we can say that 11B, there's a little button on my pen that actually counts as an eraser, and I hit it once in a while. So we have y equals negative 1x plus b. Oh. Okay, any questions on that one? How is that going? Determine the equation of a line given the slope and its coordinates. So again, we could copy this, make a duplicate. This will be easier if I do this. Clone it. I might ultimately run out of room if they keep reading grids. We say this is 12, question 12. Okay, determine the equation of a line given the slope and the coordinates. So what you want to do is start with the point. All right, so if we say for that one, we're going to use blue. So we start out at 0, negative 1, and we're going to use a slope of negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. You can also go up 2 and then the left 1, and that would work for you also. Ah, come on. All right, so that's what it asks us to do. Now, determine the equation though. So Actually, hold on. I think we were overestimating this question. Determine the equation of the. Well, this one was easy because it actually gave us the y-intercept. So I don't know why I didn't catch that. I didn't see anyone in my chat group yelling at me, but they already gave us the b. So what were we even worried about? So we would have had y equals negative x, negative 2x minus 1, just from what they gave us. So we actually didn't have to graph it. Not necessarily. It's pretty sad. It's not even early in the morning and we made that mistake. All right. Well, in the same case, look, we don't even have to think too hard on this one. They already give us the y-intercept and they give us the slope. So yeah, we could save a whole bunch of time here. Speaking of time, we're going a little longer, aren't we? So 0.25x plus the 2. I think there's 14 questions in this sheet. All right, so we didn't have to do any of that, which is a bit disappointing, but all right. Catherine's parents gave her $70 to spend on school supplies throughout the school year. She spends about $10 on school supplies each month. The graph shows the amount of money. Now, we know that she wouldn't actually spend exactly 10, but this is kind of like a scatter plot that determines it. So the graph shows how much money she has left over time. So first thing they want us to do, all right, if we could determine what would this most likely be, and maybe you can write down, would this be the slope? The $70 would be the slope or the y-intercept, or would the $10 be the slope or the y-intercept? Maybe some of you can write that down where you think. All right, definitely have fallen asleep at the wheel here. Okay, well, we start at $70, so that's our B. We start with a rate of every week, I think it is, or every month, So $10 is your slope. Okay, so determine, once you can dissect that question and find that out, determine the slope of the line. Well, it's $10 per month. Identify the y-intercept. It's $70 initial amount. And write an equation that represents the amount of money that Catherine uses. Now, I've actually made a mistake here. Can anyone catch what my mistake was? Come on, guys, you're on top of this. This is a negative. We're losing $10 every month. So that's important to note. All right, so we have y equals negative 10x plus 70. How many months until Catherine has $0 left? So do we extrapolate or substitute? Given the graph, so you're predicting 7, Jacob, that's good. How did you get that? Through graphing it and predicting, or by using algebra? Jacob, how did you figure that out? Was it with substitution? Algebra, good. Okay, so perfect, because that's what I want to show. So if we do, we want to know when she's going to have 0. So we let y be 0, because that's the total. So 0 equals negative 10x plus 70. Of course, when we bring a number over, it changes the sign. So we have now 10, positive 10x plus 70. A little bit of room at the bottom here. If we divide both sides by 10, we'll get the answer that Jake predicted, or that he solved. All right, so it's good that we know how to use the equation, or we know how to use the graph, we know how to substitute. Multiple ways to do this. Last question. Warren makes a 10% commission. So commission, you know, is a rate on every pair of shoes he sells. So all of a sudden we know we have a commission of 10%. Now, how do you want to ask yourself, we don't really want to put things with a percent sign, so we immediately change 10% to 0.10. You don't really have to have 0, okay? But that would be our rate for every pair of shoes. Each pair of shoes costs $80. All right, so he gets 10% of $80. So 10% of $80. Okay, so if you can do that, do $80. So we'll say that his commission wow, that doesn't look like, all right. Equals $80 times 0.10. And what are we going to get for that? Remove the decimal place. Try it on your calculator if you want, but basically he gets $8 of every shoe sale. Right. So pairs of shoes he sells. If he sells one, he gets $8 of commission. Okay, 2. Well, all we're going to do now is go up by. So actually, that was a bit misleading. Our slope is not 10. Our slope is actually. No, our slope is 10 because that's what we're increasing by. All right. 24. Sorry, no, it would be. Our slope is actually m. It's not really, because 10% of 80 is, that's what our slope is. A bit misleading there. Okay, so 32. All right. Determine the rate of change in Warren's earnings for each pair of shoes. So I think we did that here. Graph is in a table. Okay, well, we're going to go back to our last page then, I guess. Grab this graph. Now, we could probably grow this, enlarge this to focus on just this L portion. Okay, so he has earnings on this side. And he has a number of pairs of shoes. Okay, and we probably want to, well, the bottom is fine because our numbers never get much higher than 4. They don't go higher than 4. But our numbers on the y-axis go to 32. So you're going to have to adjust that a little bit. So I don't know, we could do by fives probably. So we might just block out what's here and go, go up $10 every, go up $5 every line. What did Jacob say? Can you save these examples? Yeah, or I'll send them out as a video, I guess. Okay, so we take our table of value information. We have, oh, I'm probably should do a different color. So at 1, it was $8, roughly there. At 2, it was $16, roughly there. 3 was 24, and 4 was 32. And so again, we can ask ourselves, we talked about this before, can you sell half a shoe or half a pair? Not really. So in that case, when you can't get in between and you can't have in between numbers, you always use a dashed line called discrete instead of continuous. It's not like the amount of rainfall and plant growth. Those could be like, you could have decimal numbers, you could have halves and quarters. You can't have halves and quarters or decimals of pairs of shoes, then it's discrete and we have a dashed line. All right, write an equation for this. This is Lucy. All right, she doesn't want to be on camera. Write an equation that represents the earnings. So we had a slope, a slope of 8 and a y-intercept of 0. So we had y equals 8x. All right, how many pairs of shoes does Warren have to sell in order to have a commission of $96? Okay, well, on our graph, we didn't give ourselves enough room for that. So we could go back to Jacob's method that he suggested before and say substitute. Substitute $96. Actually, we'll say substitute y equals 96. Now, you wouldn't put x equals 96 because you're not getting 96 pairs of shoes. Y represents the money, the total earnings, and x represents the number of shoes. So y equals 8x, 96 equals 8x. Divide both sides by 8. X equals, what does that give? Like 12 maybe, guys? Okay. 12 pairs. And that's it.